Okay, for question 1, we want to find the number of people per square mile. So usually the unit here is our denominator. So if you want to find number of people per square mile, usually we will use total number of people, which is 570,000 people, divided by the total size of the land area, which is 68 square miles. Okay, so this ratio is number of people per 1 square mile. So this is approximately 8400. Okay, because it asks us to round it to the nearest 100. Unit here is people per square mile. Okay, any questions? No? All right, next. Question 2. Joe and Joanne each bought 12 ounces of coffee with no cream in a 6-ounce cup. Joe drank 2 ounces of his coffee and then added 2 ounces of cream. Joanne added 2 ounces of cream, stirred coffee well, and then drank 2 ounces of her coffee. What is the resulting ratio of the amount of cream in Joe's coffee to that in Joanne's coffee? Okay, so if we want to find the ratio of the cream in Joe's coffee to that in Joanne's coffee, first of all, we need to find the amount first, right? So let's say first, what's left in Joe's coffee? So for Joe, initially he has 12 ounces of coffee, right? And with no cream. Then he drank 2 ounces of his coffee and then added 2 ounces of cream. So how many ounces of cream left in Joe's coffee? It's 2 ounces, right? So let's make a note here. The cream in Joe's coffee is 2 ounces. So next, we need to find the amount of cream in Joanne's coffee. Let's suppose the cream in Joanne's coffee is X ounces. This quantity is what we want, right? It's unknown. We need to find this quantity. So what relationship can we have according to the expression here? Okay, so initially in Joanne's coffee, there are 2 ounces of cream in 12 plus 2 ounces of mixed coffee, right? And after she drank 2 ounces, the coffee becomes 12 ounces and the cream is X ounces. So we have this relationship, right? The ratio of the cream in the coffee remains constant because it says here, she stirs the coffee well. So according to this, we can solve X is 2 by 12 over 14, which is 24 over 14, which is 12 over 7 ounces, right? Okay, we can just leave the ratios here. And the question asks the ratio of the amount of cream in Joe's coffee. So we want to find the ratio between Joe's cream and Joanne's cream. Right? Joe's cream is 2 ounces. Joanne's cream is 12/7 ounces. So the ratio should be 7/2/12, which is 7/6. This is the amount, this is the ratio we're looking for, right? Okay, have a look at this. Any questions? No? Okay, let's see the next one. Question 3. My plane burns 4 gallons of fuel in 3 seconds. How many gallons of fuel do I need to fly for an hour? Okay, so first of all, we need to find the efficiency of the fuel, right? 4 gallons in 3 seconds. Okay, that means for 1 second, you will consume 4/3, right? So 4/3 gallons per second. And how many gallons of fuel do I need to fly for 1 hour? 1 hour is 3600 seconds, right? So the total amount of fuel we need is 4/3 gallons per second times 3,600 seconds, which is 4800 gallons, right? This is the total amount of fuel you need. Okay, so let's make the conclusion. For 1 hour. Okay. So look at this. Any questions? No? Okay, let's see the next one. Question 4. I have 2 cartons of eggs. 20% of the eggs in the first carton are red, while 25% of the eggs in the second carton are red. If the second carton has 3 times as many as eggs as the first, what percentage of my eggs are red? Okay, so suppose I have X eggs in the first carton, because we don't know the total number of eggs, right? So we just use an X to denote the total number of eggs in the first carton. So basically for the first carton, we have some red ones, right? So how many red ones are there? It should be 20% times X, right? Because it says 20% of the eggs is red. So the red eggs are 20% times X, because X here is the total number of eggs. And for the non-red, how many are non-red? Of course, the remaining 80% times X. These are the non-red eggs in the first carton, right? Okay, so how about the second carton? Second carton, total number of eggs are 3 times as many as eggs as the first, right? So the total number of eggs in the second carton is 3x. And we also know that in the second carton, there are 25% of all eggs are red. That means 25% times 3x, right? These are the red ones. And for the non-red ones, of course, the remaining 75% times 3x. These are the non-red ones, right? And now we want to find the percentage of my red eggs to the total number of eggs. So red eggs over total eggs is, so what's the total number of red eggs? We need to add the red eggs in the first carton and the red eggs in the second carton, right? So that means 20% of x plus 25% of 3x over total number of eggs is x eggs from the first carton and 3x eggs from the second carton, right? Okay, so now let's calculate the ratios. So this is 0.2x plus 0.75x over 4x, right? Okay, so let's combine the numerators, which is 0.95x over 4x, which is 0.95. X's are canceled with each other, right? 0.95 over 4, which is 0.2375. So this is a ratio. If you'd like to write it in percents, that's 23.75%. Okay, so let's make the conclusion. Therefore, 23.75% of my eggs are red. Okay, have a look at this. Any questions? Oh, okay, let's see the next one. Question 5. Alice changes size several times. The ratio of her original height to her second height is 24:5. The ratio of her second height to her third height is 1:12. The ratio of her original height to her fourth height is 16:1. The tallest of these four heights is 10 feet. What is her shortest height? Okay, so we don't know any of the height here. We only know we know the tallest height, right? And we know the ratios of certain height to another height. So first of all, suppose we use a letter X to denote her original height. So suppose her original height is X. Makes sense, right? And according to the first piece of information, her original height to her second height is 24:5. So if her original height is X, what is her second height? So this amount, suppose this amount is y. So x times x to y is 24 to 5, right? So what is y here? Y is 5 over 24, right? So the second height is 5 over 24x. Do you understand? Any questions here? Because x to 5 over 24x is 24 over 5, right? Okay, so now let's consider the next piece of information. The ratio of her second height to her third height is 1 to 12. So this is 1 unit. And the third height is 12 unit. So that means the third height is 12 times as high as the second height, right? So the third height is 5 over 24x times 12. Okay, so what else do we know here? Last piece of information. The ratio of her original height to her fourth height is 16 to 1. So that means her fourth height is 1/16 to her original height, right? So the fourth height is 1 over 16x. Okay, so which one is the highest? Which one is the tallest? Of course, this one is the tallest, right? Okay, so that means the tallest is 10 feet. And then we can easily solve our x, right? Okay, so that means 5 over 24x times 12 equals 10. So that means x is 10 times 24 over 5 times 12, which is 4, right? Okay, so now we know that x is 4. Of these 4 heights, which one is the shortest? This one is the shortest, right? So the shortest height is 1/16 times 4, which is 1 over 4 feet. Okay, did you get it? Any questions? So let's put it here. Okay, any questions? No? All right, let's see the next one. In a far-off land, 3 fish can be traded for 2 loaves of bread, and a loaf of bread can be traded for 4 bags of rice. How many bags of rice is one fish worth? Okay, so what relationship do we have here? We know that 3 fish equals 2 loaves of bread. Right? And we also know that 1 loaf of bread equals 4 bags of rice. Okay, so what does it mean here? That means if we put the second relationship into the first one, we will have 3 fish equals 2 times 4 bags of rice. Correct? Because if we time a 2 to both sides of the second equation and substitute the 2 loaves of bread in the first one, we will have the third relationship. Okay, so that means 3 fish equals 8 bags of rice. So how many bags of rice is 1 fish worth? So that means 1 fish is worth 8/3 bags of rice. Right? Any questions? No questions? Okay, let's see the next one. Question 7. I need 40 square yards of clothes to make curtains for my room. Unfortunately, the store only sells clothes in square meters. If there are 0.9144 meters in each yard, how many square meters of clothes must I buy? Okay, so basically we need 40 square yards, right? And we need to convert it to square meters. We don't know what's the number here, right? Okay, so suppose 40 square yards equals X square meters. So how do you make the conversion? First of all, we need to know the conversion rate, right? We need to know 1 yard is how many square meters, right? This is called conversion rate. So how do you find this conversion rate? We find it from the given information. We know that 0.9144 meters equals 1 yard, right? But pay attention here. This is conversion rate between meters and yard, not square yards and square meters. So how do we find the square yards to square meters? We can simply square both sides of this equation, right? Okay, so that means 0.9144 square meters equals 1 square yard, right? Okay, So now you know 1 square yard worth of 0.9144 square meters. So how many square meters out there for 40 square yards? So that means 40 square yards now worth of 40 times 0.9144 square meters, right? We need to calculate this one. Let me use a calculator here. 0.9144 to the second power and times a 40, which is 33. Sorry. That's 33.44 and this is approximately rounded to the nearest 0.01. So this is approximately 33.45 square meters. Okay, any questions? This is our final result. No questions? Okay, let's see question 8. Each 25 square inch thermal tile on Space Shuttle costs $130. How much does it cost to cover the entire 2,000 square foot bottom surface of the shuttle? Okay, so we know that 25 square inch costs $130, right? And here we want to know the entire 2,000 square foot worth of how much dollars, right? So first of all, if we can convert the square foot to square inches, we know that the total surface cost how much, right? So from the given information, we know that 12 inches equals 1 foot. So note that we need to square both sides of this equation to get the conversion ratio from inches, square inches to square foot, right? So that means 144 because 12 squared is 144, right? 144 square inch equals 1 square foot. So that means now we have 2,000. 2,000 is on the right hand side. 2,000 square foot. So that equals how much square inch? and you calculate this number. This number is now 144 times 2000, right? Okay, so that means 2000 square feet is 144 times 2000 square inch. So what does it cost? It cost 130 over 25 times 144 times 2000. This is the total cost, right? Okay, so let's calculate this. And this number is 1497600 dollars. Hey, any questions? Okay, pay special attention to the conversion rate problems because you have made a lot of mistakes here, okay? No questions? Okay, let's see question 9. The acceleration caused by gravity is about 32.2 feet per square second. There are approximately 3.28 feet in a meter, and there are 60 seconds in a minute. Determine the acceleration caused by gravity in meters per minute squared. Answer to the nearest 100 meters per minute. Okay, so if we want to change 32.2 feet per second squared to something meters per minute squared, we need to know the conversion rate from feet to meters and the conversion rate from seconds to minutes, right? Okay, so first of all, we know 3.28 feet equals 1 meter, right? So this tells us that 1 feet equals how many meters? 1 over 3.28 meters, right? Okay, what else do we know? We also know that 60 seconds equals 1 minute. Okay, so this tells us 1 second is 1 over 60 minute, right? But again, pay attention here. We need to know the conversion rate from seconds squared to minutes squared. So we need to square both sides of this equation. So that means 1 seconds squared equals 1/60 squared minute squared, right? Okay, so 32.2 feet per second squared is actually 32.2 times 1 feet over 1 second squared, right? Okay, now we need to convert the feet to meters. So that's 32.2 times 1 feet is 1/3.28 meters, right? So in this way, we convert the unit feet to meters. And 1 square seconds is 1/60 squared minutes squared. And now you can see we successfully convert the unit from feet per second squared to meters per minutes squared. All you need to do is to calculate the numbers here, which is 32.2 times 60 squared over 3.28. Unit is meters per minutes squared, right? Okay, note it asks us to round it to nearest 100 meters. So let's calculate this number first. So it's rounded to 300. Unit is meters per minutes squared. Okay, have a look at this. Any questions? No questions? Do you know how to correct it if you have done this incorrectly? Okay, next time, please remember to submit your corrections, okay? All right, let's see the next one. Hey, what percent of 84 is 210? So to calculate percents, we can simply use 210 divided by 84, right? This is a percent of 84. And result is 2.5. So that means 2.5 is 250%, right? So the conclusion is 250% 50% of 84 is 210. Okay, and question B. What number is 5% of 10% of 1200? Okay, that means, first of all, we need to find 10% of 1200. And this number times 5%. This is a new number we are looking for, right? Okay, so this means 10% of 1200 is 120. 120 times 5%. This is 6, right? So 6 is 5% of 10% of 1200. Okay, any questions? Have no questions, let's have a look at next one. A dealer currently makes a profit of X% of his cost when he sells goods. If the dealer could get his goods for 8% less while keeping his selling price fixed, his profit would be increased to X plus 10% of his cost. Find the number of X. So before he changes his cost, let's just say the cost, suppose the cost is denoted by C, and the selling price is denoted by S. That's workable, right? Before the price change, suppose the cost is C and selling price is S. So the profit now is denoted by P. And we have the relationship. P is the selling price minus subtracted by C. And we also know that this is 1 plus X% of his cost, right? Because it says here makes a profit of X% of his cost. So after the price change, what have changed? First of all, the cost has changed. Cost has changed to 8% less. Now the new cost is 1 subtracted by 8% of the original cost, right? Which is 0.92 C. And the selling price, what is the selling price? Okay, note that from the first equation, we know that the selling price is sorry, I made a mistake here. Okay, let's make the correction. Profit P equals S minus C. This should equal X% of C, right? And from this equation, we know the selling price S is C plus X% of C, which is 1 plus X% of C, right? And after the price change, it says the selling price is fixed. So that means the selling price does not change. So the selling price is still 1 plus X% times C, right? Okay, now the profit. What is the profit now? Profit equals selling price, which is 1 plus X% of C, minus the cost, which is 0.92 C, right? And also we know the profit is increased to X plus 10% of his cost. His cost now is 0.92 C, right? So from this equation, we need to solve the number of X. Okay, so now let's simplify this equation. First of all, we can divide both sides using C, right? So in this way, we will get 1 plus X% minus 0.92 equals 0.92% times X plus 0.092, right? One equation, one variable. We should be able to solve this equation. Okay. And this means 0.08% of X equals 0.012. And X is 0.012 over 0.08%, which is 15. So the value of X is 15. This is our final result. Okay. Do you have any questions? So the key is to make use of all the information and establish the equation here. This is our equation, and based on the equation, we can find the value of X. Okay, if you don't have any questions, let's have a look at question 12. The state income tax where Christine lives in is charged at a rate of P% of the first 28,000 of annual income plus P plus 2% of any amount above 28,000. Christine noticed that the state income tax she paid amounted to P plus 0.25% of her annual income. What was her annual income? So note that if her annual income is below this number, the rate is simply P%, right? And now she noticed that the rate is P plus 0.25%. So that means her income must be above this number, right? Because if it's below this number, it simply is P%. So suppose we use a letter to denote her annual income. So suppose her annual income is X dollars. So what information do we have here? The tax paid should be 28,000. First 28,000 has a rate of P%, right? And for any value above 28,000, that means X minus 28,000. For any amount above this number, the tax rate is P plus 2%, right? And also she knows that the overall rate of her annual income is P plus 0.25% of X. X is her annual income. So this is our equation. Based on this equation, we need to solve our X. Okay, so let's try to simplify this. First of all, we can time 100 to both sides of the equation, right? This will give us 28,000 P plus XP plus 2X minus 28,000 P minus 56,000 equals PX plus 0.25X. Right? Okay, next, we can cancel some terms here. So first of all, 28,000 P can be canceled with 20,000 P here. And PX can be canceled with XP here. Okay, so what do we have here? We have 1.75x equals 56000. So that means X is 56,000 over 1.75, which is 32,000. Unit is dollars. Okay. Have a look at this. Any questions? And let's make the conclusion. Therefore, her annual income is $32,000. Any questions? No questions? Okay, let's see question 13. 2/3 of the people in the room are seated in 3/4 of the chairs. The rest of the people are standing. If there are 6 empty chairs, how many people are there in the room? Okay, so here we have 2 unknown quantities, right? We do not know the number of people. We do not know the number of chairs. So first of all, we can use 2 letters to denote the 2 unknown quantities and try to find the value of the 2 quantities here. Okay, suppose there are, you can write it like this, right? Suppose there are P people and P stands for people, right? And C chairs in this room. Okay, so what relationship do we have? First of all, 2/3 of the people are seated. So that means 2/3 of P should equal 3/4 of the chairs, right? 3/4 of C. That's the first relationship, right? What else do we know? We know that there are 6 empty chairs. 6 empty chairs is 1/4 of the total number of chairs, right? So 1/4 of C equals 6. Okay, so 2 variables, 2 equations, we should be able to find the values of C and P, right? Okay, so let's label these 2 equations. First, from equation 2, we know that C is 24. That means 24 seats, 24 chairs in this room. And then we can put 3 into the first equation. This will give us 2/3 of P equals 3/4 times 24, right? So that means P is 18 times 3/2, which is 27, right? So that means there are 27 people in the room. This is our final solution. Okay, have a look at this. Any questions? No questions? Okay, let's see the next one. On Tuesday, a radio store reduces all its money prices by 20%. On Wednesday, by what percent must the store reduce the Tuesday prices such that each radio costs half its Monday price? Okay, suppose we have a Monday price M. And if the Monday price is M, what is the Tuesday price? Tuesday price is reduced by 20%. So that means Tuesday's price is 1 minus 20% of M, right? And what is the Wednesday's price? Okay, suppose the store needs to reduce Tuesday's price by X%. Okay, suppose it needs to reduce Tuesday's price by X%. So what is a Wednesday's price? Wednesday's price would be 1 minus X% times Tuesday's price, which is 1 which is 0.8 M, right? Okay, we also know that Wednesday's price should be half its Monday price. So this is 0.5 M, right? So according to this equation, we know that 1 minus X% is 5/8, which is 0.625. So that means X% is 0.375. Okay, so what is the conclusion? Conclusion is X is 37.5, right? So that means you can make the conclusion. The price should be reduced by 37.5%. Okay, have a look at this. Any questions? No questions? Okay, let's see the next one. If P is 50% of Q and R is 40% of Q, then what percent of R is P? Okay, so basically we know the relationship between P and Q and R and Q, and we want to establish the relationship between R and P, right? Okay, so first of all, we know that P is 50% of Q. We also know that R is 40% of Q. So how do we establish the relationship between P and R? We can simply use first equation divided by the second equation, right? This will give us P over R is 50% of Q over 40% of Q, which is 5 over 4, which is 1.25, which is 125%, right? Okay, so the conclusion is 125% of R is P. Okay. Have a look at this. Any questions? No questions? Okay, let's see question 16. How many pounds of water must be evaporated from 50 pounds of 3% salt solution so that the remaining solution will be 5% salt? Okay, so this is also a before-after question. Before, we have a solution of 50 pounds, right? And 50-pound solution consists of 3% salt. So the salt is 3% times 50 pounds, right? And after we evaporated some sort of water, the solution would be 50 minus X pounds, right? Suppose X pounds of water is evaporated. So what is salt here? Salt does not change. Salt is still 3% times 50, right? Only the water changes. And we know that the new solution has 5% of salt. Okay, so that means the salt, which is 3% times 50 over the total weight of solution, which is 50 minus X, should equal 5%, right? Okay, so from this equation, we can solve that 1.5 equals 2.5 minus 5% of X. Okay, that means 0.05 X equals 1, which means X equals 20 pounds. Okay, so the conclusion is 20 pounds of water must be evaporated. Okay, any questions? No questions? Okay, let's see the last one. Calvin and Susie are running for class president. Of the first 80% of the ballots that are counted, Susie receives 53% of the votes, and Calvin receives 47%. At least what percentage of the remaining votes must Calvin receive to catch up to Susie in the election? Okay, suppose here we don't know the total number of students in the class, right? So it's better to use a letter to denote the total number of students there. Okay, so suppose the total number of students, that is the total number of ballots, is X. And Calvin need to receive X percent. Sorry, X has been used. So Calvin need to receive C% of the remaining 20% ballots to catch up with Susie. Okay, so what information do we have? For the first 80% of ballots, we know that Susie get how many? Susie get 53, right? So 53 of 80% of X. So how many Calvin get? Calvin get 47% of the first 80% of X, right? And for the remaining 20%. So how many do they get respectively? For Susie, she will get 1 minus C% of the remaining 20%. That's 20% of X, right? For Calvin, he will get C% of the remaining 20%, which is 20% of X, right? Okay, so what relationship do we have here? We know that by getting the C% of the remaining 20%, Calvin shall catch up with Susie. That means the number of ballots they have should equal, right? So that means total number of ballots of Susie getting is 53% of 80% of X plus 1 minus C% of the 20% of X should equal 47% of the 80% of X plus C% of the 20% of X. right? Okay, there is only one variable and one equation. We should be able to find the C here, okay? By solving this equation, we can get C% is 62%. So that means Kelvin need to get at least 62% of the remaining ballots. Okay, so let's now make the conclusion. Okay, have a look at that. Any questions?